Duke Cancer Center, USA. His talk is going to be, he's going to talk about immunotherapy in lung cancer, the full story.
Good afternoon. Thanks again to the organizers for inviting me. When I was here last year, and when the invitation came by email, I was very excited to get invited again, and I didn't hesitate to come back. And it's been a great experience this year also. So I think that I agree with Dr. Mokhtar. Where we are now with immune therapy, as we move toward a full story, is that it's time to think about how do we get to the point where we can get to curing patients. I think that for quite a while, we've had some good results, but as people who participated in a lot of the trials, treated a lot of patients, came together and discussed issues, we actually began to say, hey, I think I cured this patient, or I think that this therapy actually cured the patient. Which we had always hesitated to say that before in stage 4 lung cancer. But I think we are getting there for some people. So what are the strategies toward the cure? And a lot of them have to do with combination therapies that Dr. Mokhtar talked about so eloquently. So some of these are immune combinations, immune therapy plus chemotherapy, immunotherapy with radiation, and PD-1 checkpoint therapy plus vaccines. So this is the second-line data in lung cancer of PD-1 checkpoint therapy versus docetaxel. And as I talked about earlier, these were positive trials. And we had positive trial after positive trial. I think some of the junior people started becoming discouraged when they saw any negative trial. Which just meant they hadn't been doing clinical research long enough. And then we saw the results for pembrolizumab in first-line therapy for patients who had tumors that are high PD-L1 scores. And this was transformational, to be able to replace chemotherapy with single-agent immune therapy that was better tolerated and had better results. And then we had some of the long-term data from some of the first trials. So this was the phase 1 Checkmate 3 trial that looked at nivolumab in a large number of solid tumors. And in lung cancer that had had 2 or 3 or 4 lines of chemotherapy, there were about 15% 5-year survivals, and most of them were progression-free. So this was really different. We're not where we need to be, but it's completely different for me to sit down with a patient with stage 4 lung cancer, and I can realistically talk about they might live 5 years, whereas I couldn't say that before. We need to move on from this. This isn't good enough, but this is different. This shows the survival for these patients. 5-year update for the phase 1 trial by PD-L1 status. So we had, for patients who had a high PDL score, 50% or higher, we had 40% 5-year survival, which is very impressive compared to what we would expect with chemotherapy. Here's a patient of mine who was one of the first patients who went on the Checkmate 17 trial. So at the time, she was 47 years old. She was a previous smoker. In August of 2012, she had an 8-centimeter tumor resected from her right lung. There were no lymph node metastasis. She received adjuvant, Taxol, and carboplatin. Her chemotherapy finished in January of 2013. About 4 weeks later, she developed right chest wall pain. Imaging showed a mass in her right chest wall. It was biopsied. It was pathologically proven to be recurrent squamous cell lung cancer. In April 2013, she went on the Checkmate 17 trial. She was randomized to get nivolumab. At this point, she was on long-acting opiates and short-acting opiates, because you can see the tumor in April 2013 was eating away her chest wall. In some measurements, the tumor was 11 centimeters in size. Within a few weeks, her pain had largely resolved. By July, she had had a major partial response. By October, there was no evidence of any cancer. This is what her CAT scan looks like now. There's no evidence of disease. And this is almost 5 years from the initiation of treatment now. About a year ago, she had her 100th cycle. So I baked a cake. So I was busy. It was from a mix. I know you're all thinking I was just another pretty face, but no, I can also cook. So this lady had received over 100 cycles of therapy because the trial said you got treatment until progression or not tolerated. So this patient had only had grade 1 toxicity, some unusual nasal stuffiness. Other than that, she had had no immune-related side effects. And she had been told to put her affairs in order because she had terminal lung cancer and she was going to die. She said, well, why would I stop? So now she gets nivolumab every 4 weeks and is ongoing. So this is our challenge. So clearly, the patient who I just showed you had a hot immunologic tumor, illustrated by the red dot on the left side of the lung here. This is an immunologically hot cancer. Often this is smokers. Usually it is a actionable mutation wild type. Often they are PDL positive, but not always. Often they have a high total mutational burden. The immune signatures that were discussed earlier are often positive, and they often have TILs, tumor-infiltrating lymphocytes, in their cancer. But then there are a large number of patients that have immunologically cold cancers. So in lung cancer, this would be a non-smoker, often actionable mutation positive, PDL1 negative, low or medium total mutational burden. The thing about total mutational burden, it seems to be either high or not relevant. So medium appears to be no better than low. So you're either in the top 20 or 30% for total mutational burden, or it doesn't matter. Often immune signature negative and often no infiltrating lymphocytes. In breast cancer terms, this would generally come out to a breast cancer that's ER, PR, HER2 positive for cold cancer, and breast cancer that is triple negative as sometimes an immunologically hot cancer. So our challenge is, how do we turn the cold immunologic cancer into a hot immunologic cancer? And that may be IO combination, IO and chemotherapy, IO with radiation, or IO with vaccine. And there are different ways of approaching this. There are a number of ways that a cancer may be able to escape from the immune system. Is my time really up? I don't think so. Anyway, so one way is ineffective tumor antigen presentation. Sometimes the cancer cell does not have any antigens that the immune system recognizes. Sometimes MHC1 may be low on the tumor. Sometimes in the immune microenvironment, there's high levels of Tregs or MDSCs or other factors that may suppress the immune system. And then sometimes there are immunosuppressive cytokines like IDO that can make the local immune environment resistant to the immune system. And then, as we've talked about extensively today, immune checkpoint negative immune checkpoints can block the immune response, such as PD-1, CTLA-4, and others. So one of the first combinations to be looked at was CTLA-4 and PD-1. So CTLA-4 is important in the antigen presentation stage of the immune response, whereas PD-1 is an inhibitory checkpoint at the time that the tumor cell is being attacked by the by the T cell. In the CheckMate 12 trial, where we combined ipilimumab and nivolumab in advanced lung cancer, we saw an improved result. So if you look on the left at the blue bar, approximately 43% of patients had objective responses with a combined treatment, combined to 23% for nivolumab alone. This was with nivolumab, 3 milligrams per kilogram every 2 weeks, and ipilimumab, 1 milligram per kilogram every 6 weeks or every 12 weeks. You cannot give the melanoma dose in lung cancer patients. It is not tolerated. So except for young patients with melanoma, the combination with ipilimumab needs to be a lower dose. When we looked at the data for PD-L1 expression, at least in this subset of patients, combination therapy was most effective in the high PD-L1 group, where in the 13 patients that had PD-L score of 50% or higher, the response rate was 90%. We have completed Checkmate 568, where we've treated over 120 patients with high PD-L scores with a combination, and a total of about 250 patients with nivolumab and ipilimumab. So we will now hopefully present this data at ASCO in an extended group of patients with combination therapy. This shows the survival for combination of ipi and nivolumab, showing promising results. Phase 3 trials will let us know if this should be pursued or become a standard of care. I think that where the future lies is in combination therapy. These are all either on the right inhibitory receptors like CTLA-4 and PD-1, or on the left activating receptors that stimulate the T cell. I think to get to the point where we convert cold tumors to hot tumors, for many cancers we're going to have to give double and triple therapy. So another area of interest is combination therapy, and I'm going to go over this fairly quickly because we've already discussed this a couple of times. So in the Empower 150 trial, chemotherapy with bevacizumab with or without atezolizumab showed an impressive improvement in progression-free survival and some improvement in overall survival. There are numerous phase 3 trials, including Keynote 189, where some initial positive results have been reported. But of course, we need to see the published data for all of these trials. This will inform us whether or not we should move to chemotherapy plus PD-1 checkpoint therapy. Personally, I think it'll be very important to look at 1 and 2 and 3-year landmark survivals, because I think that it's the durable responses that justify aggressive approaches that have increased toxicity and increased expense. Radiation immune therapy has a lot of promise. Radiating the tumor may greatly increase antigen presentation and also enhance the immune microenvironment. This is the Pacific trial that was briefly discussed, where patients received standard chemoradiotherapy for stage 3 lung cancer and then were randomized to durvalumab or placebo. It was relatively well tolerated. There was not a lot of radiation pneumonitis or immune pneumonitis. Showed a marked improvement in progression-free survival that appears to be durable at 1 and 1.5 years. So immune therapy is being extensively studied now. The Pacific trial was a breakthrough. And I do believe that it's reasonable to give durvalumab after chemotherapy and radiation. Hopefully, there will soon be an FDA approval for this combination therapy. There are studies ongoing using concurrent therapy with immune checkpoint therapy during chemoradiotherapy, and there are clinical trials that are looking for an abscopal effect, where you radiate 1 or more tumors and look to see if this enhances the systemic effect of immune treatment. Vaccine therapies have had largely a long and unsuccessful history in cancer care. 10 or 15 years ago, I used to treat a lot of melanoma patients, and there would be an oral presentation at ASCO or some other big meeting for some vaccine trial, and I would go, and they would have all these exciting biomarker results, and I'd be forcing myself to pay attention, and then they'd show the efficacy trial, and it was always negative. And I gave up on immune therapy, I really did. And then out of the blue, 5 or 6 years ago, the results for PD-1 checkpoint drugs started to come in, and it was so exciting. And I think that now we understand the science better. So that I think now, using vaccines to stimulate antigenically the immune system and being able to take the brakes off of treatment with the PD-1 checkpoint drugs and other immune therapies opens up a whole new field. These are the ongoing phase 3 trials of late development, looking at all these different approaches of vaccine. Some use cells, some use proteins, some use genomic material, some use viruses, but all are legitimate scientific approaches to trying to improve care. These are the number of cancer vaccine types that are in development. There are over 20 phase 1 trials, over 50 phase 2 trials, and then the phase 3 trials that I showed you. And these are the different types of vaccines that are now under study. And I think this is the exciting future. These show the stimulatory immune factors in green, the inhibitory immune factors in red. So we have the potential to try to activate the green factors, and like we do with PD-1, inhibit the factors that block the immune system. As it stands, if you looked at all the different targets that we have and looked at different combinations to try to block them, the combinations could be over 10,000 possible combinations. So while this is very exciting, it also is a huge challenge. We need biomarkers to let us and preclinical data to let us know how we should combine these. Because there aren't enough patients in the world, there isn't enough money in the world to look at every combination randomly. So where are we on the road to try and cure lung cancer? I think PD-1 checkpoint drugs are curing some patients, and I think that's really exciting. But we're not where we need to be. Combination therapies are needed, but there's increased immune toxicity that we have to be very careful about. There's increased financial toxicity. We desperately need better biomarkers to identify clinically effective therapy and also identify patients who won't benefit from treatment. We need biomarkers to allow rational design, and it is very exciting that this is only the beginning for immune therapy, and the future is almost limitless, and I do think that we'll get to the point soon where we'll be curing many patients. Thank you very much for your attention.
Thank you, Professor Reddy, for this comprehensive presentation. And